Well, good morning again, everybody, and hopefully you're enjoying the conference so far. I have the privilege and the honor of introducing our next session, industrial session, Las Vegas Sphere Multimedia Venue Technologies. And you probably have seen that there's something new on the horizon here in Las Vegas. It's pretty hard to miss. It's spectacular from the outside. Trust me, if you get a chance to go inside, it's even more spectacular from the inside. This is not a consumer electronics product, but what it has inside this sphere and on the outside, indeed, is the most advanced display technology, audio technology, but it doesn't stop there. It's got all the haptics and everything else to stimulate the sensors. And as we begin to see more content developed specific for it, it's going to become even more appreciated and, I think, spectacular. We're very fortunate to have the senior technical team that was involved in the design, each representing different areas of the technology, not just what you see, but also the systems that are involved in producing the content. And I think we'll find this very instructive. Throughout the history of consumer electronics, we've seen a lot of these systems which start off as industrial or business or back-end arcade games and this sort of thing. Eventually, as the technology improves, migrate into the home. We've seen that with video games and home theater and everything else. So I'm expecting that what you hear and see today relative to the Sphere is something you're going to see tomorrow in your homes as well. So we have a panel, a distinguished panel of the senior technical team. It's going to be moderated by Dr. Stuart Elby, the other Stuart in the room, the more important one. He's the Senior Vice President of Advanced Technology for Sphere Entertainment. And the organization that he works at is MSG Ventures, which is a wholly owned subsidiary of Sphere Entertainment, which focuses on developing advanced technologies for live entertainment. In this role, he's responsible for the development of new media and entertainment technologies spanning visual, audio, haptic, sensory, including those that have been deployed at the Sphere here in Las Vegas, such as, for example, the venue's immersive sound system, immersive seating, and 3D and 4D effects. Prior to joining MSG Ventures, Stu served as the Senior Vice President, Cloud Strategy and Network Technology at Inferia Corporation, where he's responsible for the P&L of their data center networking product portfolio, targeted at cloud and data center operations. He also led R&D activities in packet optical optimization. Prior to Inferia, he served as the Vice President Chief Technologist of Verizon Labs and Verizon Digital Media Services. During his tenure at Verizon, Stu had significant influence in both the architecture and the development of Verizon's networks and service platforms, including the migration to packet voice, the adoption of multi-protocol label switching, introduction of wavelength switching, and the first live carrier 10 gigabit per second long haul circuits, as well as automated digital media distribution services. Stu serves on several university and advisory boards and industry advisory boards. He holds a BS in optical engineering from the University of Rochester, an MSEE, and a PhD from Columbia University. Stuart, the floor is yours.
Thank you. Thank you. Thank you very much. Appreciate it. That was quite the intro. But this is going to be exciting, I hope, for everyone. Before we get started, this is going to be a conversation, and I'd let the folks on the panel introduce themselves as we go around. On my right, we have the video people, which we cleanly separate from the audio people on the left. All right. So Alex Lethwaite has been responsible for all of our display technology in this Sphere. And why don't you say a little bit about yourself?
Hi everyone, lovely to meet you. Like Stu said, my name's Alex Lethwaite. I have been responsible for the show systems, so that's the visual media plane on the interior and the exterior, as well as some other bits and pieces, and show development and lighting and those things that actually we had to put on the show in the building.
All right, and Deenan has been responsible for our camera development. You'll hear more about that a little bit later, but Deenan?
Hi, everyone. Dean De Silva, as Stu said, responsible for the camera development and some of the imaging pipeline things to get basically photons in on the front end to photons out on the other side.
And next to me is Eric Hockman, All Things Audio.
Hi there, as Stu said, Eric Hockman, and that's a pretty accurate description. I've been with MSG for almost 7 years in developing the audio systems for the Sphere.
And last but not least, Michael Reeves, who's been responsible for our 4D and sensory special effects work in the Sphere and beyond.
Good morning. I'm Mike Reeves. I'm the principal effects engineer for Ventures Advanced Engineering, and I basically develop all of the oddities that go into Sphere.
All right. All right, with that, I'd like to give a short intro, and then we'll start a sort of panel discussion here so you get to understand the individual technologies a bit better. But I want to frame why we've built this. You know, what was the reason behind MSG and our chairman deciding that we needed to build a large spherical structure in Las Vegas and sort of change the face of entertainment. All right, so first off, you know, as you all know, being in this room, being at this conference, technology has advanced rapidly. But unfortunately, the advancement of technology hasn't really been adopted across theaters. Theaters haven't changed all that much. If you look at Delphi Theater from 4th century BC, it's not all that different than the Hollywood Bowl from 1922. And yeah, there's microphones now and amplifiers and, you know, some nice lighting and screens, but the high-tech stuff really hasn't gone into theaters yet. And that was part of our mission, was to look at that. Where things have changed is more on the personal entertainment side. And this is really, I think, more in your wheelhouse here in this audience. Technology has certainly made its way into things like AR and VR and game simulation. Here's a driving simulator. So technology has gone into these, but these are really about giving an experience, an immersive experience to an individual. And part of the concept of a theater is that you're having a shared experience, an experience with those around you, that you will experience something together, talk about, and maybe come back, see how things appear to other people as well. So it sort of gets down to what really is the difference between individual experience and shared experience. And the goal of the Sphere was to create a shared experience, but with all the leading technology and emerging technologies that we see going into the consumer electronics today for entertainment. All right, I have a short sizzle reel here, a little bit of video, because if you haven't had a chance to go over to the Sphere, this will show you something about it. You can hit play on that. So I hope on your visit here to Las Vegas, you'll get a chance at least to go over and see the exterior. You can't really mix it, but if you have a chance to go see a show, it's definitely worthwhile. Okay, we're going to start with the screens themselves. And so, Alex, I mean, the exterior of the Sphere, as well as the interior, have really gone viral. It's blowing up social media, and maybe you can just give you know, a short description of exactly what these screens do.
Sure. So, thank you for the slide. The exterior, 580,000 square feet of screen. It is obviously a compound curved spherical screen made up of 1.3 million puck products. We call them a puck. It looks like a hockey puck, 80 millimeter in diameter, 48 diodes within that product. itself. It comprises it's roughly it's sort of a 2K image. It's not actually that high definition, but it's the sheer scale of it that makes it impressive. We did that for a couple of reasons. The first one is to talk about image resolve. So how far away from the pixels are you before the image, you can't see the dots anymore. It was a balance between how much power is available. We have to obviously fight Las Vegas sunshine. We have to be able to, power the building, put the product on the outside of the building, and not make it so cost prohibitive that it was unattainable. So it was a nice balance between enough resolution to make it look good, enough power that was available to be able to power the product in Las Vegas daytime, and then make it repeatable and easily installed. So,
Good. No, thank you. Well, focusing, I guess, first now on the interior screen, very high resolution. Talk a little bit about that and what the challenges were to create this screen.
So for those who don't know, the interior is a 16K by 16K spherical screen. It completely immerses the view, almost 180-degree sphere. It's a bit sort of, it's tilted slightly like this, so that your forefront is below you and then the back of the head is behind the highest member of the audience. There was many things here that were very difficult. First, the sheer scale. So how do we manufacture a compound curved screen, allow pixels to drop? Because when you make a compound curved screen out of LED product, the LEDs are normally set X and Y. And when you go across a curve, they obviously have to, you have to lose a pixel at some point. The pixels get closer together. So how do we manufacture that? How do we make that into panels without making 5,000 custom panels? It's 160,000 square feet inside, so it's 4.5 acres of screen. How do we install that and make sure it is sub-millimeter accurate? We had to be 0.9 millimeters accurate in 3 planes. Otherwise, you're going to see the seams. If you see the seams in the screen, it's completely ruined. The illusion is ruined. So we had to do a lot of engineering work. We had to laser measure the buildings. We had to worry about thermal changes. So when we brought the framing out from the outside of the building to the inside of the building, we had to allow the frame to cool to the same ambient temperature because the metal would expand just enough to make the intolerance seam, make the seams appear. So that was very difficult. And then data distribution. How do we distribute data across such a large area? How do we make sure that there is redundancy within that data? And that's just on the LED product. We take a step back up there. Media servers and playback systems. It's broken up into 25 4K rasters. So hey, we have 25 4K images. How do we make sure those are synced together and across those, and we can move live camera inputs, we can move changing states and filters and that sort of thing across the servers and make sure it's not perceived to the audience. Again, how do we have backup systems of that? The entire screen is a 12-bit screen, so it's a lot of data that has to go through the back of it. So how do we generate that content? How do we get it onto those systems? And how do we do it? We end up streaming it. So we stream a lot of data very fast through some extremely powerful hard drives and processors to allow that image to be on there at the same time. Otherwise, operationally, we didn't want to cut up the media and put it onto all the different rasters every day. It just would have been far too time-consuming for different shows. So we did.
That's great. No, it's exciting. It sounds like it would be certainly a challenge for a content creator to get things put into this sphere as well. You've talked about the exosphere already. I was going to ask you, so what's sort of next on the horizon for you as you look at how to expand this, make things better, go to other venues?
Yeah, we're looking at always making things efficient. We're always looking at future technologies for screens. One thing we haven't talked about is the atrium space. There is a 60,000 square foot lobby space in there that we showcase a lot of leading technologies. So if you haven't been there yet, there's quite a lot of robotics in there at the moment. There's some holographic displays. There are some other sound systems that Eric can talk about in a minute. But we're looking to advance those things. How do we interact with the audience that are coming through the building? How do we make that part of the whole experience? As Stu said, we don't want this to be an isolating experience. So it's bring yourself, bring your family. How do you interact with the building? How do you interact with that technology? How does that technology affect the show? And vice versa. We don't want those things to be separate. They should be really intertwined. So,
Well, thank you, Alex. All right. Well, one of the big challenges, as you've heard, of course, is getting content mapped into the screen, and so I'm going to turn it to Dina now, who's been responsible for our camera development, and one that's gotten certainly some publicity because it's currently sort of a one-of-a-kind is Big Sky. So what is Big Sky?
So we started with the screen technology and understanding the screen from what Alex was working on and figuring out how do we create content for it. How do you create something that gives you the sense of immersion that feels like you're there? So understanding the screen was the first part, and then we went from that to using off-the-shelf products to capture 16K by 16K with first 15 cameras and then 11 cameras, and we quickly realized that the weight and the overhead of dealing with synchronizing all those cameras, stitching them, and the processing and everything was cost prohibitive, time prohibitive, and too hard to do. So we looked at developing our own camera, and initially it seemed maybe about 5 years away to get to something where we could do what we needed to. So we started to see where the state of the art was on the foundry side, on the silicon side, on the pixel development side, sensor companies, data movement, recording, everything. And everyone that we went to that we tried to do this with said, it's not possible right now. But as we started to piece together this puzzle of what was possible in the next iteration or the next two iterations, we started to realize that we could actually build something with very high risk in terms of it's the first thing to be done in some of these technologies. So we started with the sensor. And so the first thing before you have a camera is you have to have a sensor that will work for it. So we started the sensor development, and from there, once we understood the sensor, we started the camera development, the recorder development, because we knew we wanted to be able to record at least 16K by 16K uncompressed data and be able to move it around efficiently. So not only did the camera system have to be extreme in terms of the resolution and how much data it had to move, but it had to be practical. We had to be able to take it on location and be able to shoot with it. So we then started on all the development of all the pieces, so sensor, camera head, recorder, media, and lenses, all sort of at the same time, and processing software, to do everything in parallel, knowing that within about 18 months we had to start shooting the first production that's currently playing in the venue. And we had to do it in a way that, besides being parallel, had to be sort of risk reduced and designed so that we skipped a prototype stage. We had to go straight to usable product, and usable product that could be used before all the development was finished. So about 18 months in, 20 months in, we started shooting the movie, and then it traveled to 23 countries, and we're still in development. We're still trying to finish it up. But we ended up with an 18K by almost 18K sensor, and the recording media does about 30 gigabytes a second over 32 terabytes of storage. The lens is extremely accurate from edge to edge because of the way the screen is laid out. We need very high precision all the way to the edge, because the most important parts that you see when you sit in the venue are right in front of you, which happens to be the bottom third of the lens. So that had to be designed to sort of push the limits, and that's why the camera lens is so big.
Well, thank you. That's exciting. I mean, you've talked about the developments that took place. I mean, what were the biggest challenges that you had to overcome?
Everything.
Everything.
The sensor was an extreme challenge in terms of it's about 80 millimeters on each side. So the number of dyes that we get on a wafer is really small. It's about 4 over a 300 millimeter wafer, and the the yield is pretty low, but we weren't even sure if we would get any working sensors. So that was extremely high risk to be able to do, but we had good partners there to work with. The media was hard, but doable. We sort of understood that we could get those rates, but we had to guarantee those rates in order to be able to record consistently, reliably. So that was a challenge as well. And also the design of the camera head and the recorder, utilizing a design based around very large FPGAs, being able to make those boards, being able to design all the firmware for it. And then the optics, once you have the camera, having a lens that can actually deliver the detail and the resolution that we need.
That's great. So I heard you mention, Alex mention as well, development's not done. So what's in the works?
So when we started shooting the movie, we could push record and that was it. And we could see an image on the screen. So now we're moving to get all of the sensor features integrated, the higher frame rates, the higher dynamic range modes, all of the nice-to-have features that cinematographers and filmmakers want to be able to use on a production. And then, beyond that, iterating on the sensor, iterating on the size of it, making it smaller, additional lenses, faster lenses, more unique situations where you can shoot in very small places, things like that. We also have a program with the Center for Advancement of Science in Space to be packaging the camera to go up to the space station, and we're scheduled for launch mid-year to get the whole camera system up to the space station, and then trying to take that beyond in a different phase to be able to shoot both outside the space station and in different scenarios.
Oh, that's exciting. All right, we're going to turn our attention now to audio, which certainly presented its challenges. So I'm going to turn my attention, Eric, to you, and the first thing that comes to mind is when Madison Square Garden decided that it was going to build an immersive theater, spherical theater, and I think architecturally a spherical room or a hemispherical room is probably the worst possible design for audio in terms of reverberations and echoes. What did you think when they asked you to build a concert-grade system for a spherical venue?
I knew we needed to do something completely different. The traditional sound systems wouldn't necessarily function inside that environment. The wave field synthesis was one of the first thoughts that came to mind, and in fact it's what we wound up developing and installed. And it started from a utility aspect. With wave field synthesis, beyond the creative aspects of wave field synthesis, where you can use a whole multitude of drivers to artificially create a wavefront, that same technology can be used slightly differently, so we can be very surgical about where we put the sound in the venue, because we want to put the sound where the people are, and we want to keep the sound away from where people aren't, to try to minimize any kind of reflections and such. So it started with utility, and then on the back end, and the part that actually excites me the most is the creative palette that comes along with it. Once you have that functionality and being able to provide the sound into the space, it also has an encyclopedia of creative possibilities that come along with it. And right now, with the movie and with you two, we're just in the infancy of exploring what can be done from an artistic standpoint.
All right, well, looking at a two-dimensional sort of picture here up on the screen, Eric, I mean, in some sense, it's similar to a soundbar, but what makes this very different than, say, a soundbar, what we call sphere immersive sound?
So for sphere immersive sound, this is the product that we developed for Sphere. This is wave field synthesis array. There's two types of modules there. The one that doesn't have the triangles cut out on the corners has 96 individual drivers that are all individually processed and amplified. The ones that have the triangles cut out on those are ports for a bandpass subwoofer that docks to the back of the array. So the same height and width for all the modules works. The only thing that goes deeper when we need the subwoofers is that. What's interesting about this array is that we can control both the vertical and the horizontal, and we can create very detailed and complicated waveforms, wavefronts that hit the venue. Be very surgical about areas, again, that we want to cover, that we want to avoid, and we want to ignore. So we're working in a complete 3D plane for coverage, but it's all coming from, effectively a 2D style panel.
It's interesting. So, so you have this new type of sound system that lets you be surgical, lets you get the coverage you need with audio beams. But the Sphere supporting both live concerts, so music's coming in live and having to go to the sound system, as well as pre-recorded, such as the cinematic immersive show. How do artists create audio and get it into the Sphere?
Sure. Well, let me, before I answer that specific question, let me just talk a little bit about how this is laid out inside the venue. On the creative side, we wanted a full immersive system. So there's about 1,800 modules of what you just saw that are installed throughout the venue that completely envelop the audience with sound. We have those broken down into different layers of operation. We have a environmental layer, which provides the spatial audio. We've got the proscenium layer, which is the primary audio energy for the space. Surround layer, effects extensions, surround sound systems. They all work together to form the complete sound system. What's unique about this is that each one of these arrays is capable of generating multiple simultaneous audio programs. The arrays are aware of each other. The content is aware of each other. So we can, create very good imaging and control. So here's just some fun facts of the venue. I can't read the screen from that far back, but 1,586 permanently installed modules, about 167,000 amplifier channels and drivers that, again, are all individually processed. That makes up the system. The numbers are enormous, and we need to make the venue very simple. So getting to the question that Stu just asked, how do you use it? So what we are trying to do is simplify and give creative folks the maximum effect that they can do in the venue, but try to keep it in terms that are reasonable and don't disrupt too many workflows. So on this first slide here, I'm showing that the venue, from an input standpoint, we're programmed to all of these formats. So if somebody comes in for an event and it's a mono show, they can plug in their one wire into the sound system, and we have a beam preset that covers the venue evenly. So we support that all the way up to the traditional surround formats up to 22.2, and with variations on the input side. So depending upon how the content creators made their content, whether it's ITU or SMPTE or Pro Tools formats, you just push a button and the system sets itself to the correct channel order. Again, plug and play as best as we can. Beyond the standard formats, then you get into Sphere exclusive formats where we have what we call live mode, which is kind of a hybrid of spatial plus extra granularity into the system, and then we have full granularity in the system. So we have these magic sheets, for example, rep plot of the venue. The green dots represent the primary audio channels. The blue dots represent the spatialization layer. There's some red ones that represent some ground sourced speakers in the venue. The yellow at the bottom are surround sound channels. We've got different, again, the system is infinitely malleable, so we can change this on a beat by beat basis throughout a show. So one moment you could have this, another moment you could be mono, another moment you could have 300 surround channels individual, or you could have left, center, right surrounded. It's up to what the moment of the show needs. This map that you're looking at right now, this is a cut down version of that full granularity that I was just showing you, that we're using for live acts, for example. So it gives you the illusion of full granularity in the venue, but it does make it a lot simpler for people to present their content in the Sphere. This is a picture of some of the sound system before the LED screen covered up all the loudspeakers, and you can see the array speakers, or the channels that are labeled. These are channels that are shown. 5 through 9 are the primary stripes that we're using for U2, for example. 1 through 4, 10 through 14, or 13, are effects extensions. But that's just for a moment. And then there's a bunch of hidden stuff that's going on, beneath that. So like in addition to channels 4 through 10, there's an additional 52 channels that are targeted to every seat section in the venue, and those are available all the time. There's different low frequency processing algorithms that are also running on different channel bases that are available at that. So
You're bringing up a good point, and actually kind of melds in with what Alex was talking about from the previous picture. You're showing something under construction here so you can see the speakers. The point is, for immersive purposes, you don't want the audience to see a bunch of hanging speakers, so they're behind the LED screen.
yes.
And that actually is also a critical development. I don't know if you want to say a few words.
Sure, we spent a lot of time. I'll let Alex talk on that too.
What did you say?
Yeah.
How do we like to butt heads, Eric?
Yeah.
Is it light or sound that's more important? So,
Well, so, I mean, obviously, the video guys have their requirements. They're trying to maintain contrast, they're trying to maintain resolution, and I'm just the opposite. I don't want contrast, and I don't want resolution. I want sound to go through the thing. So there was a lot of development over the years in anechoic chambers and reverb chambers and such, developing the perfect storm of pixels and substrate and electronic density, and then also from an audio algorithmic standpoint, being able to do screen compensation. So like we know what the obstacles are, we know what all the apertures and the openings are, and we know how that affects the beams that we're trying to digitally steer. So we've got compensation algorithms that are deployed inside the venue to try to minimize the artifact.
and I would like to tip my hat, actually, because I don't know if you've done it before, but have you ever put an LED screen in front of a really loud speaker? it doesn't do nice things to the LED screen. So we have the LED screen over the top of the audience. So the thing I was really concerned about is when Eric asked to turn the bass up, does it start to rain LEDs on people's heads? So
We did that.
I was extremely nervous about that. And we're very lucky in that the design of this panel doesn't have sort of one individual driver that's creating all the energy. It's really dispersed. So the beamform actually happens you can tell me, it happens in front of the screen. So a lot of that energy goes through the screen, through the gaps in the media plane, before it sort of really peaks. So we were lucky in that it doesn't vibrate the screen. We did an awful lot of testing in various acoustic chambers, and I was blown away. I just, to the point when we had it up at sort of 130 decibels, I'm standing in front of it with earplugs in and ear defenders on with my finger on it because I don't believe the screen isn't vibrating, and it wasn't. It was remarkable.
Yeah, that's incredible. In audio now, I want to turn our attention, though, to it's what you hear, but also in the Sphere, it's what you feel. And we call that feeling infrasound. And Eric, can you just describe what infrasound is and how it works in the Sphere?
So very briefly, we developed this product in conjunction with one of our partners, which is now a commercially available product. It's kind of like a shaky seat technology that's been around for years, but this is a little bit on steroids. This has a operating range of DC to about 500 hertz. There's two different versions of this driver. One has a piston where you can actually do plus or minus 15 millimeters of heave, and you can sustain that heave. In our venue here in Vegas, where you're doing the shaky version of it, they don't have the pistons, so it's just vibration transfer from the drivers. But we have about 10,000 seats in the 18,000 seat venue that are connected to these. Every 4 seats is the granularity, so every 4 seats is on an individual channel. Because they can go up so high in frequency for the right moment in a right show, the seats can talk to you or make kind of creepy audio, which is sort of again a fun side effect. But we can go all the way down to 4 or 5 hertz in the venue and create like a really nice bobbing effect. So you're sitting on your seat, but you feel like you're bouncing up and down on a boat. The other interesting developmental thing is, so it's about 2,500 output channels that are driving these seats. And time is not your friend inside Sphere just because of the enormity of the building and how slow sound travels. So we invented dynamic delay matrices that understand where the superposition of an audio object is inside the space. And in real time, it's adjusting the delay of every single one of these drivers. So no matter where you're sitting in the venue, and no matter where the audio object is in space, your seat is going to be in perfect sync with the audio component to the tactile sensation that you're experiencing.
Well, that's incredible. And this is, as you mentioned, this is commercially available. So this is one of those things, as Stuart was saying in the intro, where you start to see technology developed in a big venue like Sphere that can work its way down into smaller venues and potentially consumer. All right, well, that's exciting. I think that's it on this. And next we're going to get to sort of the last piece, but certainly an important piece. For an immersive show, it's not just the video, it's not just the audio, it's also the 4D, the sensory capabilities beyond your eyes and ears. So handing it to Mike. And Mike, 4D is a term that's used in theme parks and immersive theater industry, but what's different or special about Sphere's 4D system?
Well, 4D is actually a marketing term, not a scientific term. And it's kind of a catch-all for anything that isn't sound or visual. In the case of Sphere, we are mostly concentrating on atmospherics, which is moving air and things that can be airborne like scent.
All right. So tell us a bit about what the capabilities of the system are. I mean, you say it's moving air and scent, but exactly what can it do?
Well, here's a little bit of industry information. Most everybody is currently using what we call near-field or mid-field technology. The three pictures there are what is in most theaters commercially available now. Those are all either near-field or mid-field technologies. They're right in your face. What we have done is gone into the far field. What you're looking at there, that array, it consists of 18 units, which we call GMAPs. I'll explain what that is if you really want to know. If not, there are 72 diffusers, air diffusers in those 18 GMAPs. We can generate a muzzle velocity of 140 miles an hour at the front of the array. Now, it doesn't look terribly impressive from here. You're looking at a picture taken from about 120 feet from the array. For scale, that's what they look like up close. They're 8 feet by 8 feet by 8 feet. They weigh about 3,200 pounds.
Well, that is impressive. So what were the sort of challenges here to make this work in such a large venue?
Well, the thing that surprised me the most is that physics actually works. We tried to develop this. When I was first asked to do this, the first thing I said was, well, it's probably not possible. The big theme park operators, Disney and Universal, had been trying to do this for years and failed. We did it, and it does work. And it's a tribute to Henri Coanda and Daniel Bernoulli, whose basic principles, turns out, apply to special effects.
We'll go ahead. So you have a chart up here showing airflow, and why don't you talk about the airflows and what's sort of the magic of something like this versus, a fan?
Well, the problem with fans is they're unbelievably noisy. We don't use fans at all. We're using air amplifiers, which is a product that's been out there since, I think, 1905 was the first time they built one. They're noisy too, but we have figured out a now patented way to quiet them down, and that's what we use. So I don't annoy Eric quite as much as I might have otherwise. We generate an airflow of about 1.3 million cubic feet per minute when the system is running at full bore. We put about 150 psi into it and get that output out of it, which is fairly impressive. We're actually moving about 10% of the air inside the sphere when we do that. And it is recirculated air. We're not adding new air. We are recirculating the already conditioned air that exists inside sphere. And the primary effect we're producing in this case is wind, but it is very, very realistic wind.
So, yeah, describe what you mean by realistic winds, particularly over the distances we're talking about, which are 200 to 300 feet from where an audience member might be sitting to these devices, and how you program it.
Well, the buzzword is verisimilitude, which essentially means lifelikeness. If you put a fan down on the stage level and turn it on, nobody in the audience is going to buy that that's a wind. It's a fan. What we are generating is a laminar flow, which is then chaotic. As it gets up into the seating, it becomes turbulent and it acts like a real wind. I'm from a mountainous area where I grew up, walking around the hills, and you get breezes up there where you hear them in the trees, and 30 seconds later you get the wind, but it comes from a different direction. That's the experience you get in Sphere. It's hardly distinguishable from a real wind.
All right, and you also had mentioned scent, so if you describe sort of how that comes together, and you're showing 40 effects here.
And by the way, that's an air amplifier. That's a 9-incher, which is a big one. This slide actually relates to temperature. I should mention that we currently have deployed 3 different effects that we use in Postcard from Earth. Excuse me. The 3 effects are warm and cold air flow and scent. The actual development of the GMAPs, we have identified about 52 different effects we can do with them, and we will develop them and roll them out as needed according to the creative people who come in and ask for this, that, or the other thing. Scent is also in use in postcards. That particular canister is a scent canister. Contains 1 scent. It's an oil-based scent. It is atomized and injected through an airstream out into the wind flow. We literally have a catalog of 2,200 plus scents on the shelf, and then we develop our own as needed. There's currently one in the show which we developed specifically for that show.
All right. Well, thank you, Mike. So you mentioned there's a lot more capabilities you can do. So where do you go from here? What are your next challenges you're looking to overcome?
Well, the next challenges are to get some sleep. After that, we're already starting to noodle over some of the new stuff. We have some ideas for the next 2 or 3 things which we need to roll out with the system. The video guys will hate us, but we're probably going to get into some atmospherics, fog, smoke, that sort of thing.
All right. Well, thank you. I do have some general questions for whoever likes to take them, but sort of based on what you have all said. Thank you, guys. I guess first what I'd say is since we've been open now since September officially for the concerts, U2 concerts, and since early October for the cinematic immersive show, have you gotten any feedback, and what have you heard from audiences that kind of influence what you're doing, positive or negative? Anyone want to take that?
Sure. My personal experience after, I really like being in the elevators of hotels and hearing people jabber about the show they've just seen. And they're all excited and they're all wowed by it, and they have no idea what we've done. You know, we sort of stand at the corner of the elevator, and it makes me laugh too. And just hearing them, hearing them wowed, hearing them, I think we've done something really different. And to me, that fuels the next round of show creation, fuels the technology drive, because I think people are just so generally, impressed, and I think we've successfully achieved what we were trying to achieve, which is hard to say. How you started the presentation, Stu, about being immersed and taken somewhere else. I think the combination of all these different things we've been talking about today, is really effective. And I don't think there's many places that do that you're transported with the show. You don't just watch the screen, or you don't just hear the audio. You're really taken somewhere else. So.
Yeah, thank you, Alex. That's good. I mean, Eric, I'm actually going to ask you, because I know you deal directly with a lot of the audio artists, so you'd have the perspective not necessarily of someone in the seats, but someone making the sound.
Yeah, so I mean, it's interesting on both sides, on both the artist and the development side, as well as the guest experience. From the guest experience side, what our biggest goal was no bad seat in the house. We wanted, no matter where you were sitting in the venue, whether you were standing right in front of the stage or all the way in the back of the venue, to get exactly the same experience from an audio perspective. And through the technologies that we've deployed, we're actually able to achieve that pretty well. And it's shocking to the audience. Audiences aren't expecting to hear that quality of sound throughout the venue. From a sound perspective, for the artist and the people that are running faders for the show, it brings a whole bunch of new challenges you can't hide. A lot of times, like in an arena show or stadium show, the acoustics are so bad and the sound system isn't covering so well, the band could be making a whole bunch of mistakes and playing out of tune, and the audience just doesn't hear that at all. In Sphere, you hear every single nuance that's being performed. So there's a lot of challenges that are involved from the musicianship and the way that you mix it, but the benefits are enormous. You can do things in Sphere in that system that you just can't do anywhere else, pretty much, period, on that.
All right. No, that's interesting. And a lot of really the focus has been on the technology developed for the Sphere, but we've developed a lot of this technology in partnership with others out in the industry. And I guess want to ask, as you've worked through these developments, what do you believe its influence will be on the larger industry beyond the Sphere, both either in just sort of adoption or sort of reuse of pieces of this, or as it might even relate to standards? Anyone want to take a shot at that?
Well, I'm always eager to talk. So the development of what's next and the technologies, there are so many fascinating technologies and developments that have happened throughout the last 6-7 years of this development effort for Sphere, where, for example, in my own world, in audio, we broke all of the best-in-class stuff that's available. We needed modeling engines, but our modeling needs were way beyond the best-in-class, so we built our own. And that by itself is an entire industry. The techniques and the tools that we're using for doing audio transcoding and production tools and such, especially like when we're talking about future technologies and future venues that MSG is interested in providing, we want to be able to transplant content from one venue to another venue, or even take it into people's living rooms with the minimum amount of human intervention. So we have teams of scientists and computer coders and everything else that's working on all of these tool sets. And how do you take a show that was built for Sphere and translate that into a personal experience that you're going to experience in your bedroom. How do you be minimally evasive to content creators and not have them change up their workflow in the recording studio? So there's, I haven't totaled up the number yet, but I mean, I would probably say it's a lot of different tools and processes and inventions, innovations that we've done that are all independently, companies and or industries in and of themselves.
But I think that translates to be selfish, translates to video as well. The sheer magnitude of this screen, the data rates that we were talking about, because video wanted to do the same thing too. The boss of the company basically said, push all the boundaries, break the envelopes, break the norms. And so, we wrote the specifications for the screen and it was so high, and then we realized the data rates that went with it, it broke every step before that as well. So that's why we ended up having to make our own cameras, because the post-processing was broken, the hardware support was broken, the playback servers were broken. How do we transfer that much data around? We had to go and solve every hurdle. So like Eric said, the knock-on effects of this in the industry, I think, are significant. Simple things like storage and networks are no longer simple. We had to reinvent a lot of that stuff. So yeah, I think pushing the development boundaries of all these individual facets, it would just permeate into the industry.
There's a piece of it on the qualitative side too that we came across as we started doing testing and seeing how content works, what kind of content works, and the language of an environment like Sphere, especially with a really large audience, how that translates into effective experiences and stories is something that was completely new. So the language that works for film and cinema that has worked for the last 100 years and continues to evolve has to sort of be redefined. So all of these technologies, from the audio to the haptics to the visuals to the experience to how you look at perspective from different seats, and all impact the creative possibilities and what works and what doesn't. So simple things like framing is completely different, because you don't have a rectangle to work with to play off in terms of composition. You have to rethink how you do things like a standard close-up or an over-the-shoulder shot in a movie is completely different, because now you can look in different places, as well as you may have the audience members looking at completely different parts of the screen because there's so much to look at.
No, that's absolutely true. And actually then I'll kind of turn back, because we heard video and audio, but so you've had direct contact with one other important stakeholder in all this, which are the guys out on the men and women out on the camera shoots, actually creating it. Again, what sort of feedback were you getting? I mean, this, as you said, this was still a product in development. It wasn't even finished, and they're out in 23 countries or such with this, and not necessarily a hospitable, indoor sort of environments for this. What were you hearing from the artists that were actually out there, the director of photography, the directors, editors? What did you hear?
Well, the biggest thing is that there's so much detail and so much to look at in terms of when you look at the scene that you've captured, that you have to pay attention. You also have to, if you try to use any fake set pieces, things like that, they start to show up because it's so much detail. But the surprise for me, at least on those locations, was shooting a portrait and how well it captured a face, in terms of how honest it was in terms of the reality of the portrait it's capturing, because there's so much detail, there's so much of what you normally see and don't see because there's so much detail.
It sounds a lot like what Eric was saying with audio, is that can't hide things, right?
Well, that and the scale. So, if you have a hair that's in the wrong place, suddenly when you put it on the screen, that hair is 10 or 15 foot tall. So it's really apparent. You go, oh, there it is. And go back to the drawing board.
Yeah. This leads me to maybe a harder one to answer, but with all this incredible technology, the challenge, and I think, Dean, and you hit on it really well, is that we're trying to tell a story and put the audience into a story. It's not about the technology, it's about making the technology invisible. And the counter to that, of course, would be like a VR headset. You know, it might be a great experience, I'm sure many of you use them, but you get fatigue. I mean, after a while, you're wearing a headset and it's tiresome, and you got to take it off. That's not the experience, of course, we're trying to do in a theater. I don't know if there's anything you can comment on, any of you, about how to not make the technology kind of the centerpiece, but to actually make the story or what we're trying to convey the centerpiece.
I think there's two pieces there. The first one, the technology that we've talked about before, they have to be cohesive. So if you have one piece that's not synchronized properly or one piece that's not quite finished properly, it's so apparent that it takes you out of the illusion, so to speak. Like everything has to be very organic, timed beautifully. So, so when you're sitting in the seat and the storm scene is happening, Mike's 4D wind has to hit you in the face. Eric's audio has to rumble at the right time. The seat has to be at the right time. And if any one of those things is just off, you're immediately snapped out of it. So it has to be very well thought about. The other piece is the story has to be, in our case, I think it has to be specific for the venue. So it is such a unique set of tools that it's hard to explain, but you have to put the story first. You have to make sure that is what the audience is being drawn towards, and the technology really supports those things. And I say if it doesn't do it or it doesn't line up well, I say it immediately falls apart. So story has to come first.
And on top of story, then you have this experience that's not just like you would have in a headset, but now it's a shared experience with thousands of people, which is a different experience than even a smaller movie theater or at home with a TV set. So that experience, the story, as we discover how to tell those stories and the language to use, takes into account the shared experience, because you can see, like if you go to the venue and watch the show, there's a very consistent audience reaction to the different key moments in the story, and it doesn't change. It's like every single time it's the same exact moments, and so that becomes part of the technology and the storytelling.
I have a reaction to a little bit of that. I showed you a slide of the near-field effects, which you see in the cinemas. Those effects essentially are a squirt of air, compressed air in your face, or a squirt of water in your face. Those to me are exactly the opposite of what we're trying to do, because they take you out of the moment. What we're trying to do is make it real, so you're in the moment, so you can't tell it from reality. And that's a problem with the near-field systems that are out there now.
I'll jump on that a little bit too. To me, the audience's suspension of disbelief is critical, and the second the audience notices any of the tech, as Alex was saying, we've lost. We don't want to do anything that pulls you out of that suspension. But from a creative palette standpoint, one of the really fascinating things that we've done at Sphere is we've created an environment that offers a wide dynamic range. And when I say that, I mean visually, acoustically, and such. And we can start playing with people's sense of reality. For example, we can create an acoustical environment at the beginning of a show that you don't even notice it's just the signature of the building. But we're doing that artificially, and at the right moment in the show, we take that away, or we completely change it. You don't know what just you experienced, but you know that everything changed. So again, it's taking, we can really sculpt the entire world around the audience and give them experiences that they just really can't get anywhere else.
Yeah. I mean, that is one of the missions. As I said early on in the intro, it was a shared immersive experience, and sort of the target, the goal we're going for is to transport the audience to wherever the story is taking you. You know, you should not realize and forget that you're sitting in a theater in Las Vegas. You should be wherever we've taken you, and that's what we're going for. Not that you were sitting in a theater and, oh yeah, this cool effect happened. It's quite different, as Mike was saying. All right, I think at this point we still have a little bit of time, and I can take a couple of questions from the audience if there are any, and I can only do that by standing up, because I've been blocked. Yes.
So
Get this mic, possibly, there we go.
let me bring the mic over here, sorry. It's a big room, and we should have had 2 mics. But thank you so much.
Thank you, Stuart. It's really, really interesting talk. You know, I mean, there are few presentations that I listen word by word. This is one of them. You know, it's really interesting. My question is, do you have any like backstage tours that we could take to see this, like feel it? You know, not the shows, just the engineering part. I'm just curious.
Well, it's interesting you say that. So, no, the answer is no. We don't really do backstage because backstage is a backstage. But if you go to the Sphere experience, it'll actually answer your question, I think. The atrium, which Alex mentioned, is phenomenal architecture unlike you've seen, and it morphs, it changes with lighting. But in that space, besides just nice communal space to walk around, we have robots with AI. Things, a whole bunch of technologies, some of which go into the shows, some which aren't in shows yet, but will be. So we have robots you can interact with in AI. We have some very interesting audio demonstrations beyond what's in any show, and actually some holograms, other things. So all the new technology, as Alex had mentioned, we showcase there, and as new shows come along and want to harness that into the shows, they will. I don't know if anyone else wants to comment on that. No? So, yeah, so spend time in the atrium. If you do go to, say, Postcard from Earth, I think we let you in an hour before or something. So you have an hour really to explore all of the technology.
Question over here.
Yes.
Thank you so much. Not sure if it's a good place to raise this question, but I'm just curious about how the IP of this great innovation is protected. Is it part by part, or there is a cohesive IP for all things together?
Well, I'm not sure how to answer that. It's, there's a large patent portfolio that's been created from our work, and it continues to grow. Saying cohesive or not cohesive, it's all the inventions that have come about as part of our work in developing the Sphere.
So I had a question. I'm actually a student here at the University of Nevada, Las Vegas. So we actually were talking about the Sphere, and what was incredible is just the sheer amount of energy that's used every year. So I understand, to my understanding, we briefly talked about this. I didn't know if the Sphere was going to, in the future, I think our teacher was mentioning that 70% of the power would come from renewable sources. And I understand that maybe a deal was reached with Nevada Energy to kind of facilitate that. So I was wondering if you could just elaborate.
Well, I don't know the details. It is public information that 70% is coming from renewable energy. I think we're fortunate to be in the Las Vegas area because your typical renewable energy sources such as hydro, solar, wind are all accessible here. So from that point of view, it was an ideal location from a sustainability. So it's not. I don't think it's any one magic bullet there. It's really just taking advantage of all the power sources, sustainable power sources that are available in the Nevada area.
Gee, since he asked that question about power, I'll take advantage of having the microphone here. I think it was Alex who mentioned the need to trade off the intensity of the light against the power and this sort of thing. And I'm just wondering if could follow up on that. One of the main challenges in consumer electronics devices today are we're putting incredible amounts of processing power in the ever smaller little boxes, and we're no longer running into a processing power, we're running into a power thermal kind of issue that's here. And I don't know if there's any particular lessons that were learned from what you were doing, or to what extent the thermal management and energy management was a real challenge that, you know, could transfer over the Summit building these little tiny devices we're making today.
We're very lucky in that we didn't have the confinements of space. So, you know, we could make pretty big things and not be too worried. Yeah, the exterior, for example, is a challenge. So we had to achieve a bright enough product. But of course, you know, the sheer scale of this, once we you know, kept growing and growing, of, you know, 500 million square feet, whatever it is now, and wanted to get brighter, it used a lot of power very quickly. So
Do you have specialized thermal management fluid cooling, or?
it's because of we're in a desert, right? So you can't have any moving parts or anything like that, because it just gets filled with dust. So, you know, and it self-destructs itself. So we had to be really clever with that, and everything is passive. So the entire outside of the building is all heat sinks, it's all thermal management. There's a lot of you know, silicon transfers, you know, a lot of wafers to transfer into the structure of the building, to the steelwork and the aluminum of the building. Yeah, and everything has to be sealed. There's not a single thing up there that isn't water and dust proof, because of obviously the environment we're in. And you know, recent weather patterns have seen, you know, we've got to test that. So yeah, we spent, we had the product in the desert for about a year before it was even on the outside of the building, just running 100% capacity, you know, just as hot as it would go. We put it in the worst environments, you know, out in the desert, getting baked, you know, and then getting cold at night. And so, yeah, we really put it through its tests before we went on the outside of the building.
Okay. When Dan Brickman and I did VisiCalc, we felt we were creating an illusion. I explained to people, we're not writing a program. We were creating an illusion, and the goal was for the program to disappear. That was a success. So I've got so many geek out questions, but overall, have you seen already an impact on the entertainment industry from what you've done and from the particular technologies? And I'll close with one geek request. During this week, I saw there's a Hello World screen. Can you put a print F around it just for this week?
We can suggest that. There you go, old school.
We can ask, yeah.
Yeah. So we got another question here?
Anybody
want to answer that?
Yes, is the short answer. Absolutely.
Yeah, I mean, we do. Honestly, I mean, even before we opened, but it was announced and clear that we were opening, at least, and again, there's no science behind this. I didn't do a statistical analysis. But certainly it seems like there's more and more sort of immersive event things popping up, more announcements of you know, theaters, immersive theaters, domes, things like that. So yeah, I don't think that this is a one-off. It's going to sit here in the desert. I mean, I think there's an industry. We're at the front of that. Yeah, we're on the front of that, but I think we've opened a door that, and as Alex said, everyone loves it when they've gone there. I haven't heard anything negative about the experience. So certainly others are going to want to build theaters that can also provide that sort of storytelling.
So from an audio content creation standpoint, the industry throughout the years that, you know, when people have been creating immersive systems, you know, either binaural or 5.1, 7.1, all of the tools that they're using for both playback as well as production is single listener centric, or a small group of people in a small section. The tools don't really exist for what we're trying to do. So we've been inventing the tools for doing spatialization and oralization and modeling for a different perspective, but it's the trend of the live industry right now. So it's just like we're kind of on the leading edge, showing people, oh yeah, well, that's why it never worked before. And Well, it's both. I mean, so Sphere handles both live productions as well as recorded productions, but in the same sense, there is no one sweet spot in our venue. We're catering to 20,000 people. And the tools to achieve that are things that we've been developing. So there's, as people become aware of the tool sets that we're building, everyone that's touched it so far wants one. And they don't want to do a show again without it. I mean, and that seems to be the direction that we're moving.
So we have another question.
Okay.
Hi, amazing talk.
Yeah, closer. Yes, sir.
Amazing talk. I have actually two questions, and with my first question, I might be way off. So have you considered, or is it possible to build the audio system in the floor, like build in the ground and with some kind of mesh or something? Because, well, generally thinking, I think that would give the vibration feel, and also like it won't have any impact on the screens. So is it possible at all, or have you considered it? And my second question is a bit greedy, and I think a lot of the people here might have that in mind, but I'm just going to get the courage and ask it. Will we be getting any referral codes toward the show at all?
Well, I can answer the second part. No, not.
I told them not to ask that, but I can.
That's a fair question, but no. The first part, I mean, I'm going to ask Eric. I mean, I know that you've certainly thought about audio delivery from everywhere in the universe, so.
Right, yeah, so way back at the beginning of the project, the original idea was airborne infrasound in the venue versus the tactile system that was attached to the seats. But then when we started moving away from that and going into the tactile environment, we actually developed a patent around getting the transducers into the floor system and coming up with suspension systems. And that also deal with antenna systems and cable raceways and such. So trying to come up with a whole integrated solution. But yeah, that's still very much in our radar for future development of ways of creating, a sound / physical experience in ways that not just, move the bar, but are totally unique and elevate guest experiences in a way that people haven't imagined. So, yes.
What happens if you drop your beer?
Yeah.
Yeah. Hi, a bit closer, yeah. I'm incredibly impressed. It's everything's turned up to 11. Each of those individual technologies, I'm like, oh yeah, I understand how that works. Oh, you've really pushed it. It's very impressive. And I think some of your innovations for virtual reality going forward, you're almost a metaverse company, arguably, in the whole thing going forward. But I have a friend of mine who's security background, and he would kill me if I didn't ask this question, because you're the perfect panel. It's a bit of an awkward one as well. In fact, when they mention the awkward one, this is the one I think is the real awkward one. How paranoid are you guys about if somebody hijacks the outside of that? Just
Super
for whatever
paranoid.
reason, it just must be, it would just, when I run a VR lab, the amount of insurance stuff I have to fill out when I'm showing people and experiments, just the paranoia on that, just to ask you.
Yeah, no, paranoia is very high, which is good. We do have a dedicated InfoSec team, of course, that stays awake. I don't know that they ever sleep, worrying about these things. The architecture itself, I mean, we didn't have someone on the panel to talk about networking, but that was obviously a big piece of this. One way to think about Sphere is it's this really cool entertainment venue that's built on top of a data center. And a lot of this is, when Alex said he's streaming the video, it's not streaming from outside. This is all internalized, large data center is part of the structure, dedicated non-internet connectivity. So that obviously your friend or you will know that that's not 100% because there's threats that are beyond just cyber threats from the outside. But no, extremely careful. And again, part of our culture, and this goes to some of the things Dean was talking about, is Hollywood and cinema. I mean, we've changed the way storytelling is done, but again, there's always that paranoia when you're creating content, so it's not just the building, but yes, we live in a constant state of paranoia on the InfoSec side.
So I'm just want to compliment you guys in terms of you energized our audience. We rarely get these sorts of questions, and I'm going to be very selfish here because we have other people want to ask questions, but I want to get mine in as well. I remember in the early days of which television was invented, they got the technology right, kind of like you guys did, and then they started asking the question, well, what is it good for? And the imagination was, well, we'll stick it into a theater, and we'll just, whatever's on the stage that's a play, we'll put it on there. So obviously, we're in the very early stages of the creative content for this, and there's got to be a huge bunch of content creators who don't know how to take advantage of that yet. What sort of tools, beyond maybe the camera and capabilities, are you going to make available to content creators so that they can, maybe they can't experience being inside that, but at least they can start thinking about how to develop content that fits the sphere?
Yeah, no, that's a great question. I'll hand it over to some of my colleagues here, but one thing we didn't talk about is we do have a studio in Burbank, California, called Sphere Studios, I guess is obviously the name. And it is I won't say replica, but it is the Sphere, quarter size, Alex? Yep. Quarter size, but full resolution. So we just compressed everything, so it's the same resolution. And then we have tools that Eric talked about in audio that, again, you can work offline. You don't have to be in the Sphere. So the idea is to continue to develop these tools that can be used into our Burbank studio, as well as even in people's home studios on the audio side, some of the video editing side. And with those tools, they could, you still need to end up in the Sphere and do your final work, but the idea is to get most of the way there and have those creative tools. But like you said, we're in the first stage. We have one show, Postcard from Earth. We have a band playing, U2. There's others coming, and we're constantly developing tools to make it easier for more artists to come in, more quickly.
There's actually a learning curve. So typically there's an artist or a band or a creator that comes to us with an idea. And we say, love the idea, now come to our studio, because you have to understand the medium you're working in. And that affects every point of people that are sat here with me. So you're like, how do we start positioning cameras? How are we going to start filming this? How do we even start post-producing this? How do you edit that? How do you get, when that person wants to have an intimate conversation on the screen, how do we put that into place? And so they have to start learning all the different tools. And we help them, because we want them to be successful too. But they come to our studio and we help them and start to create the different palettes and different concepts and tools and audio and experience to sort of piece all those things up. Because it's overwhelming if you do it, you just try and jump in the deep end. You have to sort of break it apart and think about each line.
We've also built a bunch of tools on the VR side, so you can see what the content looks like from different seats. And we've used this a lot on set where you might be positioning a camera, but you want to see where the horizon is, you want to see what's in frame, you want to try to get an understanding for the experience before you hit record. And so the VR tools have been extremely helpful, and it's very much part of the standard workflow now, where you might be shooting, on the side of a volcano, but you're looking at it in the venue in a VR headset while you're framing. Those kinds of tools have been extremely useful.
Yeah, thank you very much for the impressive talk. I have one question regarding the imagery, the capturing of the imagery. We saw the camera and the innovations related to it. Have there been also some innovations regarding the capturing of audio, or is it artificial audio? Because you said there is it needs to be realistic and it needs to be synchronized. So could you comment on that, please?
You want to talk about audio capture, Eric?
Sure. So we actually have a capture team, and that is their whole mission in life, is to figure out the best way to go out there and get the audio. And there's a whole bunch of innovations that we're working on with that. From, like, for example, for the infrasound system, we want to create that sense of realism. So we're looking at contact microphones and accelerometers and all kinds of other interesting ways of capturing the complete experience out in the field. as well as, phased array microphones and artificial intelligence on parsing that data, so we can be getting source localization and isolation from a complex capture. And we're also working with Deanon and his team on other interventions for like using LiDAR and understanding what the focal length is on the camera lens to create tools for the content creators to try to minimize, again, the amount of time that it takes to get content in through editorial and ready to get into the show. So anything that we can do that can assist on the speed or the spatialization or the overall guest impact, that's all part of the program.
Repeat question.
I think, I don't know, Mike, if you want to say something about this, because we've talked about that as well.
Yeah, we've been developing a tool which is intended to go out in the field with the film crew, which captures all of the environmental parameters that are going on when the shoot is happening, so we can reproduce them back in the studio.
So I have two questions. The first one is, what percentage of women you have in your technical team? Because I mentor a lot of girls as a woman engineer to become, to go into fields like yours, And if you have very little women, just want to know what are the skills that you're looking that we could let the girls know that they could develop to be in your team, for an example.
All right.
Maybe a controversial thing, but just one point.
So Alex runs the production technology team, and maybe, I think over in Sphere Studios is probably where the bulk of the employees are.
Yeah, there's approximately like 350 employees in LA at the moment that are either involved with R&D and technology development, but also production of the movies and the events themselves. I don't know the statistic, but I have a lot of women on my team. Probably 40% of my team are women. I have everything from project management to coders to material experts to electronics engineers to all sorts of backgrounds. It's one of the best things about our Sphere Studios is that I come from a sort of concert touring background. Deanon comes from a cinematic background. Eric's come from Eric and Mike really have both theme park backgrounds. So we've come from all sorts of entertainment divisions, and it's a real interesting mix of people there. And I think that's one of the reasons we're so successful.
All right, so I was the keynote on AI, so I have to ask this question. What's your plan in terms of how to use AI in your business models and technologies?
That's such a broad question, but actually there's sort of a simple answer. I mean, the complexity of creating an immersive space is one that we could do using existing tools. I mean, we did get the first show out the door. It took, I don't know how long in terms of post-processing, editing, both audio, video, everything else. So in general, I'll say we're looking at AI as a means to augment and speed up all of that post and editing. So there's no one place, because Eric already mentioned things in audio and audio capture and parsing, creating tracks out of a complex capture, knowing what was the sound of a bird versus a person, et cetera. Video and rendering, there's just a whole bunch. So it's a very broad range. Again, what separates, I think, what makes it a challenge for us in general is that we're talking about large theaters. So it's not, I think most people think of AI today as like chatbot or something, right, or whatever it is, but you're doing one thing, one person's interacting. Here we're trying to create an environment with many different viewpoints coming in physically, in the geometry. So there's a complexity there that would certainly, we're not the experts in AI, but certainly trying to find, work with partners and find ways that will improve the overall experience and do it in a way that is realistic from a feasibility, viability point of view to create a show.
There are some problems that are more, there are some problems that are easier for us to tackle with machine learning, where it's focused on more concrete input and output for what we can train to what the result is. And there are some things that when we look at how to use AI to solve it, it's not at the place yet where it can be 100%, and so that sometimes proves to be a real challenge because our benchmark for quality is so high that even getting to 95% means that you have to have a human in the loop to guide it. So all of our explorations on the AI side tend to lean towards how do we get it far enough to then hand it off, or how do we develop the tools to be able to have the right parametric controls that then a human can take it from there. So it's more like assistive at that point, or it's more deterministic in terms of the training versus the output can be tightly coupled.
Very good.
So we're coming to the end of the allocated period. I don't think we have time for more questions, but I wonder if anyone on the panel or you, Stuart, would like to make a couple closing remarks or things that you want to leave the people with. You've said so much already, but...
No, I don't have anything new to add, but you've been here. Hopefully you've seen the outside of it during the week. If you get a chance, if you are staying through CES or we'll be back, definitely go for the Sphere experience. That will absolutely let you start to see the technologies behind the walls, behind the screens, and get a sense of where it's going. And the atrium is a living space. I mean, there will always be new things coming into it over time as we're developing new capabilities. Certainly appreciate everyone's attention today. Hope you found it as interesting as it has been for us for the last, 6 to years trying to design and build the thing. Thank you.
Well, I've been living here and watching it, so again, thank you so much. We're going to break now for the awards, but I want to leave the members of the panel here with a very small token of our appreciation. We can't possibly compensate them for their time, but it's a little bit of advertising for the Consumer Technology Society, and I hope they enjoy it.
Display it on the Sphere.
Yeah.
That's lovely. Thank you very much.
Thank you. Thank you, Stuart.
I think we're one short.
Thank you. That's all right.
Let me see if I can find a...
What would take the remote?
So if I could ask the folks that are going to do the awards to get themselves ready, and
Four caps for them?
yeah, we need to get another one.
Oh, so he's going to give you this one.
Okay.
Four caps, okay?
Did he going to give one?
He's going to give his one.
Oh, good,
Yeah.
okay.
It's not right.
Okay. Yeah, if you guys could hold off on the lunches, don't pick up the lunches yet, we're a little early. But help yourself to coffee if you like. Hold off for the lunches.
Do you have it or you need a dongle? Okay, give us a second. I'm going to switch it over to the screen to see if you can see it.